Hello! This is going to be my walkthrough of how to write the Firefly model up in Mesa, the agent-based modeling platform in Python. So here is the question. We have fireflies that can synchronize their flashing. We want to make an agent-based model to do so. Important steps. Fireflies are going to be our agent, and they're going to be the only agent walking around and doing things in our world. We don't even need an environment. We don't need a background. We just have fireflies living in the cells and nothing else. So we're only going to make one agent class. Now it's going to have a clock cycle. It's going to keep track of what time it is. And after it reaches a certain amount of time, say 10 time steps, it is going to reset its clock. These fireflies will then flash at a certain time, the first step of the clock, and they will continue on with their clock, and they're going to be dark the rest of the time. So at time 1, they flash. Time 2, no flashing. 3, no flashing, etc. Up to time 9, no flashing. Time 10, no flashing. Time 11 is cycling back to time 1, flashing time. Okay, so it will be also, we'll come to this step next about adjusting based on other fireflies. But let's get a firefly going. Let's try to simplify this and get an agent working that can flash at a certain time. So we'll add in the neighborhood adjustment next, but I want to do something simple to get going. So I am going to start a new notebook here and make some progress on coding up some fireflies. Okay. Firefly notebook. Make some imports for it. Import numpy as np. We're going to do some plotting later. So from plot 9, import everything, import pandas, and then inline and special for this one. We usually don't add, but we're doing stuff in Mesa. So from Mesa, import agent. And we're also going to need to import other things. Later on, we're going to make a model. And we're going to be making time simultaneous activation. We also need import from space the multi-grid of where they live. And that's enough to get us going. I misspelled things. Import. Good to catch those early. All of our libraries are set up now to do some basic processing here. Okay, so we need to make an agent. Let's go get that started. First block here, we're going to say let's make a class Firefly based on the agent. Now all of our classes here in Python, we init them and they bring in a self to know who it is and other critical things to make this Firefly work. Agents need a unique ID. In order to make them work and identifiable in the rest of Mesa, we have to have a unique way of saying Agent 56, Agent 82, Agent 85, it's your turn to do something. And so that unique ID is going to be critical. It is important that we know the position, an XY coordinate of where this agent is in the world. And we want to have a connection to our model. Where do we live? So we can talk to it and ask it questions. So to get us going, we need to say, wait, I'm an agent. The agent setup needs a few things. We need the unique ID and the model connection. Okay, so now the Firefly brings in a few things. It says, yes, I'm an agent. I have all the agent things. And then we save the extra stuff that we added. Let's save the position. Okay, this makes a Firefly for us. This makes it an agent. We have a position. The next thing we need is the clock. we need to say, where are you keeping track of your time? What time is it? The clock is going to tell us that. And I'm going to start this off at a random number between 1 and 10. So self.random.rand int 1 to 10. Now self.random, because it's an agent, agents need to access randomness. And so we're going to be able to do this in a consistent way so that everybody isn't trying to make their own random number generator. That's why self gets a random. It's usually, we would say like np.random or just random.something. But in Mesa, it's helpful to have it all organized as one random number generator so we can replicate things if we need to. Okay, so what do we need to determine? We need to determine if we're flashing or not. Let's make a really nice function here, is flashing. Hey Firefly, are you flashing? What did we say? Return if self.clock equals 1. If it's time 1, we're flashing. If it's not time 1, then we're not flashing. So this will be a nice true or false statement that comes back and make it easy for us to ask and answer this question later. Okay, we need to now figure out how to move on to the next time step. In Mesa, we need to do a step. And it has to be named this exactly. You can't add other parameters in here. It has to be step self, otherwise it gets really confused. Because it is an agent, and because you belong to the Mesa hierarchy of other things, you need to fit in. So the step needs to just have a self. Now what it's going to do is it's going to say self.clock equals self.clock plus 1. That would make our time go on. And then we could say if self.clock is greater than 10, self.clock equals 1. This is our timer that moves it one step along and then pushes it together. Okay, this is good. I have an agent, and that agent is flashing, and that agent will be going through the time and figuring out if it's flashing or not. This is enough to get us going. No, it doesn't fit everything that's being asked for in the question. But this is something we have to do, is to take something that is a bit more complicated and just break it down into something that is super simple for us. Okay, let's make a model. We have a Firefly agent. Next thing we want to do is make a model. So let's make a class Firefly world based on the model. Again, we have to do an init, self. Models need a height and a width. I'm going to say they're 30. And they also have a call to super. This gets our model created. We are now making a model in the Mesa world. Okay, two things are important to our model. Our model needs to keep track of time and space. Self.schedule equals simultaneous activation self, and then self.grid equals a multi-grid based on the height, the width, and we're going to say torus equals true. So we have a two-dimensional grid. Lots of things can be in the same spot, and we have time, and we want to be using simultaneous activation. We'll come back to that in a second, but everybody is going to get a step. Simultaneous is a way for us to make it look like everybody takes their step at exactly the same time. It's not important right now, but it will be as we go forward. Okay, I want to make some fireflies. Let's make 200 of them. Let's put out their positions. I am going to make it a random number. Again, 0 to width minus 1. And the other piece, self.random.randint 0 to height minus 1. This gives me a tuple, which is going to be a random spot. Let's make a Firefly. I'm going to call the init, which brings in a unique ID, the position, and the model. So let's set that up. Now, cool models in Mesa, you can get the next available ID. If everybody needs something unique, it's good to have somebody who knows all the numbers. Say, what's an available number? Because I need something unique. When you say self next ID, we need to pass in the position we just created and pass in the model. Okay, our fireflies are created, but until we put them into space and time, they don't really exist. So self.grid, let's place the agent at this position, and self.schedule add the agent. So this places the agent in the grid at a particular position, and this schedules the agent to do something with time. Okay, last thing we need here, self.running equals true. Perfect, that initializes us. We need to set up the step for the model as well. Okay, now when a model steps, it needs to say self.schedule take a step. And then let's add an ending point. It's nice to add these into our models. If self.schedule.time is greater than, say, 500, self.running equals false. Okay, so we have our Firefly world sketched out now. We have created space and time. We are all powerful. We have made 200 fireflies, and we've set it up to say what happens when the Firefly model needs to step. It calls the scheduler, and the scheduler is going to be the one that calls the step of each firefly to make them flash or not. Okay, if we want to start visualizing this, we can either go take this code and put it inside some directories and write a visualizer, or we can start to do the data collection piece. I want to go forward with the data collection piece and do the portrayal and stuff separately. So let's stop the video here, and the next one is going to pick up of how to turn these into something I can make a data frame and do some plotting with.